Yesterday we looked at how to solve for missing sides in a right triangle. Today we're going to look at how to solve for missing angles. The starting point is the exact same. Label your triangle. But in this case, your reference angle is going to be the one that you are looking for. So in this case, it's x. Now, like always, across from the right angle is my hypotenuse. Across from the x is my opposite, and the leftover is adjacent. And now you're going to circle the two sides that are given to you. In this case, opposite and adjacent. I don't want to circle an unknown side because I already have an unknown angle. I can't have two variables in my equation. So in this case, we're dealing with opposite and adjacent, which means we're going to use tan for TOA. So I'm going to write my original equation, tan theta equals opposite over adjacent, and I'm going to plug in what is given to me. I'm going to replace that theta with x, 15 for opposite, and 20 for adjacent. And now, whenever you're looking for a missing angle, you're going to be using the inverse function. In this case, we have the tan trig ratio, so in your calculator, you're going to type in tan inverse. Now, this is the notation for tan inverse of the ratio. Tan, it looks like tan to the power of -1, which isn't a thing. That's just the notation for tan inverse. And it's pretty much your calculator trying to figure out what angle it should plug in for x so that you get that ratio of 15 over 20. Now, in your calculator, you're going to be using either the second function or the shift button. So you're going to hit shift or second, tan, and then you should see that tan inverse notation. And then in the brackets, if you have a fraction button, great, put 15 over 20. Otherwise, you can just type in 15 divided by 20. And for angles, we usually round to the nearest whole number. So in this case, I'm going to use the squiggles again. I get 36.869, so I'm going to round that up to 37 degrees. And that would be my final answer. If I wanted to find the other angle, like let's say I want to find angle B as well, I could just subtract 37 and 90 from 180 and get that angle as well, just in case it told me to solve fully. Okay, let's try another example. My reference angle is the x. I'm going to label my triangle. So the 12 is the hypotenuse because it's across from the 90 degrees. The 5 is opposite because it's across from x. And then my adjacent is that leftover side. So I'm going to circle my two known sides. So that's opposite and hypotenuse. And opposite and hypotenuse, OH, that's going to be part of SO. So we're going to use sine. So sine theta equals opposite over hypotenuse. And now I'm going to replace. So sine x equals 5 over 12. Be really, really careful that you plug in your numbers properly. For sine and cosine, your fraction, if you were to simplify it, has to be less than 1. So if you're to turn into a decimal, it better be less than 1, or else you're going to get an error on your calculator. So if you're to take a sine inverse of a fraction that's greater than 1 and you get an error, that doesn't mean your calculator isn't working. That means you messed up your fraction. For tan, it's okay, but for sine and cos, that is not possible. So just a heads up about that. And now, because I want to solve for an angle, I'm going to use my sine inverse function. So I'm going to type in shift sine 5 divided by 12. And when I round it, I get x is approximately 25 degrees. And that's it. Label your triangle, circle the two given sides to choose your ratio, and then you're going to take the sine inverse to find your angle. Let's try two word problems. A ladder leans against a building. The foot of the ladder is 16 feet from the building. The ladder reaches a height of 14 feet on the building. Determine to the nearest degree the angle the ladder makes with the ground. So our measurements are already labeled for us. We just have to know the angle between the ladder and the ground. So that's this angle right here. You can label it whatever you want. You can label it theta, you can label it x, it doesn't matter. I'm going to label it x though. And that's going to be my reference. So let's label. Opposite would be 14. I have a right angle here, so the ladder would be my hypotenuse. And then the ground is the adjacent. Opposite and adjacent, we're using tan again. So tan theta equals opposite over adjacent. I replace, so tan x equals that 14 over 6. And again, whenever you're looking for an angle, you're going to be using that inverse button. And that's why I said in the previous video that solving for angles is actually a little easier and quicker than solving for sides, because it's always that inverse button of your fraction. So now when I plug it into my calculator, I get rounded 67 degrees. Now remember in the last example, I said that sine and cos can't have a fraction that is greater than 1. For tan, it's perfectly fine. Like 14 over 6, that's 2.3 repeated. And it's okay to take the tan inverse of that. But if you were to try to take the sine or cos inverse of 14 over 6, you're going to get an error. So just keep that in mind. Anyway, let's write our therefore statement. Therefore, the latter makes an angle of 67 degrees with the ground. Okay, let's try the last example. A boat sails from Port North for 2.8 kilometers, then west for 4 kilometers. What is the bearing back to port now? So our boat started right here. It went up north for 2.8 kilometers, then to the west for 4 kilometers, and we need to find the bearing. Now, I'm just going to zoom into this diagram for a second. The bearing we are looking for goes from north all the way to this line right here. Okay, I already know that this angle is 90, but I need to figure out this question mark angle, so this little piece here in the triangle, and add it to the 90 to get the actual bearing. So my actual bearing goes from here all the way to my line. That's what I'm going to be looking for ultimately. Okay, so I'm going to call that theta for my bearing, and this angle in here, the question mark, I'm going to call it x. So let's label our triangle. Across from the right angle is my hypotenuse, across from x is opposite, and then the leftover is adjacent. So opposite and adjacent, once again, we are using tan. So tan theta equals opposite over adjacent. Tan x equals 2.8 over 4. And again, we take the tan inverse of 2.8 over 4. And we're going to get approximately 35 degrees. And now this is not our bearing. Okay, our bearing is the 90 degrees from the diagram plus the 35, which gives us 125 degrees. Now you were given the diagram, so that helps. Okay, so now we can write our therefore statement. Therefore, the bearing is 125 degrees. Now there are different notations for bearing, like it doesn't always have to be from true north, but for the purpose of this example, because we're given the diagram, that's what we're going to use as our bearing, from true north to the direction going back to port.